Hi everyone, welcome back. In this video, I'll explain how DevOps started, why it became important, and the key milestones in its history. Also, we are going to understand what CI/CD is, why it matters, and how it helps bring DevOps to life. So let's begin. Before DevOps existed, software development used a very traditional model. Developers worked on one side and operations worked on the other side. And these two teams barely communicated. Developers would finish their code and simply throw it over to the operations team. Operations then had to deploy it, run it, and fix problems, often without understanding how the code was built. Then came new ideas. Agile encouraged faster delivery and teamwork. Lean taught companies how to remove waste and improve flow. Systems thinking helped teams see the whole process instead of blaming each other. These ideas become the foundation of what we now call DevOps. Several important events helped DevOps grow into what it is today. 2001, the Agile Manifesto was published. This started the shift toward faster, collaborative, and development. 2006 and 7, early tools like Hudson, now known as Jenkins, introduced in continuous integration. 2009, the first DevOps Days conference was held in Belgium. This event officially introduced the term DevOps. 2010, CI/CD pipelines become widely used in the tools like Jenkins, GitLab CI, and GitHub Actions. Cloud computing made automation and scaling easier. Around 2015 and later, DevSecOps and SRE, site reliability engineering from Google, further improved reliability and security. DevOps wasn't created only to use new tools, it was a major cultural and technical shift. Its main goals were deliver software faster, reduce failures and downtime, improve collaboration and break silos, automate repetitive tasks, build reliable high-quality systems, create a culture where everyone shares responsibility. With DevOps, developers and operations work together from the start, planning, building, testing, deployment, and monitoring as one unified team. The software development lifecycle, or SDLC, is a structured process used to plan, create, test, deliver software. Its main purpose is to reduce mistakes, save time, and produce high quality software. It helps teams follow clear steps like requirement gathering, design, deployment, testing, development, and maintenance. Without SDLC, projects become unorganized and risky. The waterfall model is the oldest SDLC model. It moves step by step: requirements, design, development, testing, and deployment. And you can't go forward until each step is finished. The V model is similar to waterfall but adds strong testing. Every development stage has a matching test stage, forming a V shape. The iterative model builds the software in small versions. Each cycle creates a part of the system, tests it, and improves it in the next round. The agile is very popular today. Work is done in short sprints or 1 to 3 weeks with customer feedback, quick changes, and continuous improvement. The spiral model mixes iterative development with risk management. Each loop includes planning, risk analysis, development, and evaluation, useful for big and high risk projects. These are the comparison table of these models, comparing between all the features of all models as long as their advantages and disadvantages, also showing the best use of the models. DevOps is built on strong collaboration. Instead of developers and operations working separately, DevOps brings them together as one team with shared goals. Automation is the core of DevOps. Teams automated code building, testing, deployment, infrastructure, and monitoring to move faster and avoid manual errors. DevOps promotes continuous improvement. Teams make small, frequent updates, learn from failures, and improve their process every day. DevOps depends on good metrics and monitoring. They track system performance, errors, server health, user activity, and deployment results. DevOps always put the customer first. Every change aims to improve user experience and Teams use feedback to adapt quickly. Amazon uses what they call two-pizza teams, meaning each team is small enough to be fed with two pizzas. Amazon deploys updates every 11.7 seconds on average. This allows them to intentionally fix issues, improve performance, and ship customers-focused features faster than competitors. Google uses Site Reliability Engineering or SRE. SRE teams continuously analyze incidents and write postmortems and improve reliability step by step. They treat failures as learning opportunities, not blaming games. Netflix uses continuous monitoring and even chaos engineering where they intentionally break systems to test resistance. Netflix uses a powerful automated pipeline called Spinnaker. The developers commit code, the pipeline automatically tests it, packages it, and deploys it across thousands of servers without human involvement. CI means continuous integration. Developers regularly merge their code so bugs are caught early. CD means continuous delivery or deployment. After CI, the system automatically prepares or releases the code. The application is always in a ready to deploy state. The main goal of CI/CD is to automate the entire software release process. Faster deployment cycle, early bug detection, more reliable releases, better team collaboration, shorter feedback loops, and fewer production issues. Teams use many tools for CI/CD such as Jenkins, GitLab CI, GitHub Actions, Circle CI, Argo CD, Azure DevOps, and Bitbucket pipelines. A CI/CD pipeline usually follows 5 steps: code, build, test, deploy, monitor. Code. Developers write and commit changes. Build. The system compiles and packages the code. Test. Automated tests check the errors. Deploy. The app is released to staging or production. Monitor. Performance and issues are tracked continuously. CI/CD supports DevOps by improving collaboration, automation, and fast delivery. It reduces manual work, lowers human error, and helps teams deliver updates to users more quickly and reliably. So if you enjoyed this explanation, don't forget to like and subscribe. See you in the next video. Thank you.